Okay, I know folks have questions, but like any good conference, we're running behind time. So I want to invite up Chris Farr, who's a project manager in the Energy and Power Solutions Group, who has experience with combined heat and power and utility distribution. And I'm going to use hand signals for the 5 and 2 minute warning, since pretty soon we're going to have hungry people coming in here for lunch.
Yeah, I'm super excited for this opportunity to speak at Eco Districts. I haven't been to this conference before, but I definitely feel like I'm with my people. So it's great to hear all of these wonderful success stories. And I'm going to tell you another one that's very local. It's actually just a few blocks down the road here for the University of Minnesota. They had put together a utility master plan about 15 years ago, looking at a lot of the aging infrastructure here on the campus and trying to determine where they wanted to go, what they were going to need to improve to maintain their utility systems, and how they could do so in a reliable, cost-effective, and sustainable manner. Okay, so yeah, energy management principles, basically the way they make most of their decisions is all about reliability, sustainability, and cost-effectiveness. A lot of the same things that we think about on all of the projects that we're studying here. So one of the things that their utility master plan identified was that the campus was growing and a lot of the heating equipment was reaching the end of its useful service life. They actually had a couple of large, still coal-fired boilers that were put in the 1940s that they really wanted to retire. One of them was already in a state of disrepair and they really didn't want to invest in keeping it going. So they started to look at, well, what do we do? Do we just go in and put in a couple of new boilers and kind of maintain the business as usual? Before they did that, they tried to take a look at, well, how can we be more efficient? And as anyone who has ever calculated their carbon footprint knows, a lot of your carbon footprint is directly related to your consumption of purchased utility power. The electric energy that you purchase from the grid, a lot of it still does come from fossil fuel powered plants. And when you do that, you're purchasing electric energy that's really only harvesting about 32% of that available energy that's in the fuel being combusted. So, most of the rest of that energy is just being lost to the atmosphere in the form of heat, or to a river or to a lake or wherever you're rejecting your heat to. So when they looked at this, they said, okay, we have a need for heat, we have a need for power. This may be a good opportunity to put in a combined heat and power plant. So by a raise of hands, how many people have a basic understanding of how a combined heat and power plant work? Okay, that's good, very good. So I think most people are pretty familiar with this. I won't go into too much detail, but basically you're looking at improving your performance efficiency from about 49% to use a mix of purchased electric utility power and then heat produced through a conventional boiler versus 75% overall efficiency if you can produce your power on site and then capture that waste heat. So basically that solves all of their goals. It's a cost-effective solution because even though it requires a large investment up front to construct, you're saving a lot of energy throughout the life of the plant, so these systems can pay for themselves in a relatively short period of time. They're much more sustainable. Again, going back to the carbon footprint, if you can produce your energy more efficiently, if you can harvest more of that energy from your fuel source and utilize that, it really makes a significant difference on your carbon footprint. And then reliability. When you're an institution like the University of Minnesota is a Tier 1 research facility. Many of the problems that still vex us as a civilization are being studied here, and they're looking for solutions around those problems that can advance our society forward. So, having reliability in the utility systems to support that research, to support the medical facilities, it's absolutely critical. Having the ability to produce your own power on site in bulk allows you an additional layer of protection against, a major utility outage across the state that could be caused by a transmission grid problem or something else. So, in this case, we're using combustion turbine technology, which is about 99% reliable. It's really not down very often for service. So it gives them just another opportunity to power all the critical loads on their campus. So we started putting pencil to paper and we said, this is what we got to do. But now we actually have to make it happen. So there were a few different facilities that were evaluated. Land in Minneapolis obviously is hard to come by. This is a very built-out area. One of the facilities that we looked at was a industrial brownfield site. It was an abandoned heating plant that was built in 1914. When the university acquired the Southeast heating plant from North Star Energy in the 90s, they essentially mothballed this old plant. So by the time we got there in 2011, this thing had been sitting abandoned and unused for nearly 20 years. The roof was leaking. All of the equipment was abandoned in place. I mean, there was still coal in the hoppers. The lights didn't work. 5 minutes, okay. The lights didn't work, and you know, I mean, we were wearing respirators and mining helmets to get through there and try to figure out what it was we were working with. So it was really a liability for the campus anyways. It's right on the banks of the Mississippi River. They knew they needed to clean it up. They knew they needed to get rid of it. But there were a million different obstacles that we were going to have to tackle to be able to reutilize that facility. This is what it looked like at the beginning of the project. So you can see the proximity to the river. So obviously, you know, the cleanup effort, we had to be very, very careful to make sure that none of those materials made their way into that waterway. I threw in just a couple of photos. This is us going through here with our flashlights trying to figure out, you know, what's in the building when we got there. You know, we're finding chemical tanks left behind and, you know, friable asbestos insulation coming loose everywhere. So we decided to use the site not just to redevelop that brownfield site, but also because it was a strategic location. So as you can see from this diagram, the little point on the Minneapolis campus map to the left there, that's the utility plant. The greatest thing about that site was that it was originally a heating plant, and all of the steam and condensate distribution systems to the campus ran through the basement. So we're already connected to a system that we can use to distribute our energy, and we were centrally located between a couple of the major switching stations on campus through which we could distribute most of our power. And so I just want to show you some of the numbers we ran. So we looked at what would it cost, what's your absolute minimum investment that you have to make to maintain reliable service to the campus. Well, they needed to replace those two boilers that were past their useful service life and add enough capacity to keep up with future growth. And then we said, well, how much more money do I have to throw at this if I want to go combined heat and power instead of conventional technology? We ran one option that had a couple of 7.5 megawatt turbines, and then we did one with a single 22 megawatt GE LM2500. And basically we said, okay, you're going to add an additional $40 million to this project. That's a steep price tag. But in doing so, look at how the cost of annual purchased utilities drops. It goes from 25.7 down to $18.9 million a year. 2 minutes, okay. I'm going to go quick here. And so over 20 years, and you know, this plant has got at least a 30-year design life. Just in the first 20 years, they're going to avoid $167 million in combined utility and O&M costs. So the project definitely pays for itself. Now this is even a more stark picture that I wanted to paint. Right now, if you look at all of the electric energy and heat that's consumed on this campus, their carbon footprint for all of that energy, and this is over 10 million square feet, this is a big campus, their carbon footprint is about 205,000 metric tons per year, or it was before CHPP. Putting in this turbine has knocked that down by 15.8%. That's a big number for anybody who's tried to cut their carbon footprint. 15.8% is huge to come out of one plant. Also want to talk about air quality. So we talk about carbon, right? That's the bigger global warming picture. But this morning we were also talking about, you know, the rise in asthma symptoms and just the air quality in the area. So, you know, not only does improving your fuel consumption efficiency improve your carbon footprint, it drastically reduces the amount of NOx, of carbon monoxide, particulate matter, and sulfur dioxide that you're releasing into the atmosphere. And some of this also comes from getting away from the coal technology and replacing that with the CHPP. So now that the project is finished, you can see that it took a lot of work. We had to rebuild most of the structure of the building from the inside out and reconfigure it for the new plant. Just to the right, it's hard to see in this photo, but the heat recovery steam generator is about 4 stories tall. It actually starts in a basement below this level and runs all the way up to the roof. It produces about 250,000 pounds per hour of steam when we're using full duct firing. This is the electrical conduits that bring the power from the utility grid into our 15 kV switchgear. We have our generator then connected to that, and all the power goes back out to the 2 switching stations, and most of the campus right now is connected to this building. That's a view of the break room. You can see again how close that is to the Mississippi River. So basically, the thing I want to point out is that these projects, they're very expensive. They take a lot of owner engagement. They're very time consuming, but if you can plan energy sustainability or energy efficiency and sustainability into them, these things can pay for themselves. You can take these types of facilities that are very problematic and they're eyesores in your community, and you can turn them into assets that you can use to build upon a sustainable future. That's it. Thank you.